All right, so we want to graph some sinusoids. First one says y equals 4 cosine x minus pi over 4 plus 1. All right, plus 1 is just going to be a shift at the end. The last thing we're going to do. We always start with the function, and we always start on the inside of x, okay? So I picture the cosine curve, the general cosine curve. All right, from 0 to 2 pi, from 1 to negative 1 for a range. And this is just y equals cosine x. All right. And then there is nothing happening, no multiple here, right? So it is a period of 360 degrees or 2 pi, right? It is not getting stretched or compressed, okay? So then I look and say, it's shifting. Okay, a negative means it's shifting to the right. And what is a parabola or a sine, so it doesn't matter. So instead of being at 0, it's going to shift it pi over 4 to the right. So I would have a working drawing here, and I'm going to make a finished graph over here. I'm going to just change this to pi over 4. And as dumb as it sounds, I'm just going to write 2 pi over 4, or 2 pi plus pi over 4. Do we all agree? Everything shifts to the right. All right, so now I've handled the inside. Now the next step is just start working my way out. I work my way out to the multiple of 4. That is a stretch, right? So 4 times 1 is 4, 0 times 4 is 0, negative 1 times 4 is negative 4. Taking care of everything here. And the last step is to shift the entire graph up 1. So it becomes 5, 1, negative 3. If it's on a pre-made graph, 1, 2, 3, 1, 2, 3, 4, 5. And this would be 0, and then there would be pi, 2 pi. I'm just going to try to get it, I know that at pi at bottom, so pi over 4, so I might just put that dot here. I know at 45 it's supposed to be the max. A little bit beyond it's supposed to be the max. And again, this is not, all right, it's not an exact graph, but there it is. I mean, it's not the greatest curve, right? Do we agree? But that works. That's a sketch that would be there. Oh, label our axes. X and Y this time. All right. So there's the first one. The second one, maybe we'll change the theta just to make sure we understand the difference. All right. And I said I'd do the next one in degrees. Here again, I will tell you right away, this is plus 2. This plus 2 is just a shift. That's the last thing we handle, even though we put it in front, right? That's just going to shift the graph upward in the end. All right? And if you look at the problems, like we are at 5.5 in our textbook, poll here. So we got that shift. So I'm going to start with the sine, and I'm going to start inside here. I think of the sine curve, and then I'm going to deal with 2 theta. So I think of y equals sine theta. So I make theta my axis. And then this is just a standard curve. And a standard curve would be 0 to 360 degrees. Okay? But this multiple on the inside makes things happen more quickly. Right? Because you picture yourself, and this is what I always do. Okay, what happens if I plug 360 in here? 360 times 2 gives you 720. Well, what makes this 360? 180. So this has, again, 2 curves at 360. So the first thing I do is I just change that to 180. All right? Because again, 2 theta equals 360. What value of theta gets the whole curve done? 180. Okay? All right. Now, I erase all these little pencil marks here I have. So I'm sitting at 180, and I know this. So now, I know it was from 1 to negative 1. It has a center line of 0. Right? So the standard curve has a standard range, negative 1 to 1. Now my multiple is negative 3. There's 2 ways to look at this. I'm going to do it my way. I'm going to look at it as a multiplier of 3, and then look at the negative. It mirrors it across the horizontal axis. So the multiple of 3, which I just double underlined, changes this to 3, 0, still 0, and negative 3. This negative sign mirrors it the other way. I just did in blue, right? That's what the negative sign does. And then the last step here is to shift the curve up 2. And again, that's a plus 2. I'll do it in yellow here. I think it's negative 1, up 2, and 5. So again, I'll make a quick little sketch of this. Blue. Blue is my favorite color today. It didn't have a shift in it. I make the curve I want. It's centered. If I have 0, whoops. If I have a graph and it's 0, there's negative 1, 1, 2. That's my center line, so I kind of see it. 3, 4, 5. My sine curve starts here. And I know at this point, I'm at 180 degrees. This is 2, this is 5. And again, I'm not saying this is the best graph known to man. It's not. But that's the situation we have. And again, working through shifting the graph. It's just all in the shifting. Again, comes with practice. All right. So the next one here, number 3. Again, I don't even have to have the 1 there. I can probably just leave that off, right? But 3 plus sine of 3x plus 120. One of the big things we need to realize is that this multiple, that sine x is like the f of x part of the equation. So we have to have the multiple outside phase shift. Every time, you've got to factor the period out to know the shift. All right? So, or you can do it the other way. You could set, you're right. And what Jason's saying is, you know the standard sine curve operates between 0 and 360. And you can solve this inequality, this compound inequality, okay? And if you do that, you're going to get the same answer that I'm going to get, okay? You're going to get the period here. One curve happens from negative 40 degrees to 80 degrees. You notice that's 120 degrees of separation. All right? The way I do this, personally, is I stick that it's all part of a shift. All right? But again, if you memorize just that every curve operates 0 to 360, you can solve that compound inequality every time. So I start again with the standard sine curve. Because again, I know that it's x, it's y. I know its range is 1 to negative 1. And I know that the standard curve happens in 360. The first thing I know is that 3 curves are happening. This 3, right? 3 is 360. So I change 360 right away to 120. Right? Because 3 curves are occurring. The next thing I do is I deal with the shift. Plus 40 is 40 to the left. So I was at 0 and 120. Shifted it left puts me, and I'll do it in red again, negative 40 and 80. And guys, you know if that matches right there. Right? You have to make a decision when you practice which way it goes. All right. So now I have the curve, I have one curve set. So now my multiple here was 1, right? I don't have to do anything, all right? So the last thing I got to do is shift it up 3. So 1 becomes 4, 0 becomes 3, 3 plus negative 1 is 2. My amplitude, this number here, the amplitude here and here is still 1. All right, so it matches. Just double check. So again, if I make a graph, if I had a graph given to me, 0, 1, 2, 3, 4, and a lot of times I would just personally, I just like to put a dotted line if I have a center line, this center line in my head, if I'm making a graph. Negative 40, I don't know, back here a ways to 120. You know, again, I would make sure to label. I might move that 0. Oh, wait a second, I said 120. It's fine. I meant 80, didn't I?
So if it's not funny,
You can draw it. You can do this, yeah. And I'm pretty sure on the midterm. Alright? I'm letting you make your own graphs. But again, we have to be able to do it both ways, alright? And going forward, this will become more of a multiple choice question often for us, because that's something we should be able to quickly identify as we get there, so it doesn't take the time. Alright? Last one. Alright, so on this problem again, the one thing I want to make completely clear is this is the last thing we deal with, right? We're going to shift the whole curve down 3 at the end. And the first thing I got to deal with is this. And again, I'll do both methods. You either say to yourself, hey, I know that half x is equivalent to 1 period of 360. You multiply and you find out 1 period of 720 degrees. Or you set up the inequality. And you say a standard curve happens between 0 and 360. Multiply everything by 2, you get 720. Again, either method. You end up with a curve happening over 720 degrees. Again, we can picture it in our heads, all right? I'm not going to draw it this time with the numbers. I'm going to say, hey, there's a sine curve, 1 to negative 1 for the range, 0 to 360 would be the domain of one curve. But this time we know it goes all the way to 720, so maybe I put that on there. All right, and again, I know it goes 0, 1, negative 1. Now I'm just going to multiply by 2 first. So it goes, that's this number, right? Multiple first. And the last thing we got to do is shift it down. So everything's got to be shifted down 3. So I think it becomes negative 1, negative 3, negative 5. And that's where I'll stop. Again, we'll label the y. And the variable here was given to us as x, horizontal. And those are 4 sinusoid curves.